Hello guys, welcome in today's session. I am Professor Fayyaz Kawadi from Department of Mechanical Engineering. With continuation with previous session, in today's lecture we are going to learn tool geometry. In that tool geometry, we are going to study which different angles are provided to single point cutting tool and the nomenclature and tool signature, that means how the tool is defined. From unit number 1, theory of metal cutting from manufacturing process to subject. So let us start. The various angles of the single point cutting tool have great importance. Each angle has its own function and specialty. Here you can see the image or three views: front view, top view and side view. This is front view. In that, two different angles are provided. This is top view. In this, you can see two different angles are provided to single point cutting tool. And this is left hand side view as per third angle projection method. In that, you can see two different angles which you can see in side view. That image you have to draw in the examination, showing different angles which is provided to single point cutting tool to make it as a single point, and each angle is its significance. The first angle which is given to the raw material or blank shaft is nothing but a rake angle. A rake angle is the angle between the tool face and a plane parallel to its base. In previous session, we have already learned which is the face and which is the base. So again, I am showing here, this is the base on which that tool is mounted in tool post, and this top surface to be grounded, that top surface is called face. Okay, so the angle made by this face with this base or line parallel to this base is called as a rake angle. According to two different views, this rake angle is classified as back rake angle or top rake angle, and second one is side rake angle. These two angles you can see in two different views. This back rake angle or top rake angle, in some books that is given back rake angle, in some books the name is given top rake angle. So back rake angle or top rake angle you can see in front view, and side rake angle you can see in side view of this geometry. So top rake angle, if the inclination is given, if the inclination of face is given towards the shank, this is shank. Okay, so the inclination of face, this place is inclined in towards the shank, then it is called as top rake or back rake angle. In this two-dimensional view, you can see that back rake angle, that inclination you can see here, this inclination is given towards the shank. This is shank. This angle made by face with the line parallel to the base, this is base. This inclination is called as a top rake or back rake angle. If you see the cut section of front view and the vertical cutting plane you consider, you can see here red color image as a section plane or cutting plane. Okay, so that angle made by this face, this is face, this face is making angle with the line horizontal or parallel to the base. The angle made by this face is called as a rake angle, that you can see in front view. Here you can see the front view. This is front view. So top rake angle or back rake angle you can see in front view. Okay. The advantage of this back rake angle is it removes the chip away from the workpiece smoothly during the machining process. Due to the back rake angle, the chip moves away from the workpiece easily. Second one, provides easiness in the manufacturing process. That means in cutting process, and it increases the life of tool. That is the advantage of back rake angle. Second one is a rake angle is an important factor to judge machining action. The value of a rake angle can be positive, negative, and 0. Okay, so according to the rake angle or back rake angle or top rake angle is again further classified as negative back rake angle, which is provided for while cutting the brittle material like cast iron. At that time you have to provide negative back rake angle to the cutting tool. Second one, positive back rake angle. It is used for cutting ductile material. And third one is a rake angle. It is used generally for brass material, which is again a ductile material. Again, it is a soft material. So for easy removal within less time and by taking large depth of cut, at that time you will go for 0 rake angle for soft material. The value of rake angle determines the value and power requirement, the life of cutting tool, and the chip deviations. The value of a rake angle varies from minus 15 degree to plus 15 degree, but in some cases it can reach up to 30 degree. Now, in the same category, the side rake angle. When the inclination of the face is measured towards the side, if the inclination of face, this is face, this inclination when measured towards the side, this is the side, this is side of that tool, this is side of the tool, when that inclination of face measured towards the side of the tool, it is known as side rake angle. And this side rake angle you can see in side view. The inclination of face, this is face, and the angle made by this face and the base or the line parallel to the base, this is base, and the line parallel to the base when measured towards the side, this is called as a side rake angle. Side rake angle. This side rake angle you can see in side view of that tool. It provides clearance between side flank and the workpiece to prevent rubbing. When the tool start rubbing against the workpiece, at that time, that means that side rake angle is reduced here or removed. At that time, you have to grind the tool to provide the side rake angle. So this is side rake angle. Second angle is a relief angle or clearance angle. A relief angle or the name clearance angle is given because it relieve the material or it provides the clearance for removing the material from bottom. It is the angle between the tool flank and a normal line drawn from the cutting point. So this is the cutting point. This is the cutting point, or it is called as a nose also. Okay, so the angle made by tool flank. Okay, tool flank. This is tool flank. Again, there are two flanks as we see yesterday in previous session, major flank and minor flank. So this is the one flank. So the angle made by this flank surface and the line perpendicular drawn from the cutting point, this angle is called as a relief angle. A relief angle. Again, that relief angle you can see in two different views. So again, further it is classified as end relief angle and side relief angle. Also, there are two flanks, a major flank and minor flank. So there are two relief angle also, end relief angle and side relief angle. Now, what is end relief angle? The angle between minor flank and perpendicular line to the base. The angle between minor flank. This is minor flank. This is minor flank and this is major flank. Okay. So the minor flank angle made by minor flank and perpendicular line to the base. This is base. To that base, if I draw the perpendicular line, so angle made by this minor flank and the line perpendicular to the base, that angle is called as a end relief angle. You can see here end relief angle. Okay, that you can see end relief angle in front view again. Front view again. Okay, so is that clear? Therefore, it avoids the rubbing with workpiece against the tool. If that angle is not provided, there will be material, and if area of contact between the workpiece and the tool flank is more, so rubbing action will be more and heat generation will be more, so tool life will be less. So to increase the life, small angle is provided here. That angle is called end relief angle. Okay, and that is in lateral direction. Clear? End relief angle. Now come to next in the relief angle is side relief angle. The angle between major flank and perpendicular plane to the base. The angle between major flank, this is major flank. That angle, side relief angle, you can see in side view. Side relief angle. Okay, the major flank and perpendicular plane to the base. Perpendicular plane to the, this is base. If I draw vertical perpendicular plane to the base, okay, so angle made by major flank and perpendicular plane to the base, that makes a right angle with side. That makes a right angle to the side. This angle is called as a side relief angle. You can see in that image side relief angle, you can see in the side view. Okay, side relief angle, the angle made by major flank and the plane perpendicular to the base, that angle is called as a side relief angle, and it also avoids rubbing with workpiece against the same as end relief angle but in a longitudinal direction. Now third angle is a cutting edge angle. Cutting edge angle, again there are two planes, two cutting edges, side cutting edge and end cutting edge, as we study in the previous lecture. So that end cutting edge angle is again further classified as side cutting edge angle and end cutting edge angle. Now let us see what is side cutting edge angle. Side cutting edge angle is an angle between side cutting edge and parallel line to the shank. Okay, this is side cutting edge and this is end cutting edge. If you see the terminology of figure, this is side cutting edge, this is end cutting edge. So the angle made by side cutting edge and the parallel line to the shank, this is shank. So if I draw the parallel line, the angle made by these two lines is called as a side cutting edge. The same angle is called as a lead angle also. The another name for side cutting edge or is called as lead angle. Now come to the next angle is end cutting edge angle. It is an angle between A and cutting edge. This is A and cutting edge. A and cutting edge and the perpendicular line to the shank. There is a shank. I draw the perpendicular line. So if the angle made by A and cutting edge and the line perpendicular to the shank is called as a A and cutting edge angle. These two angles you can see in top view. Top view. A and cutting edge angle and side cutting edge angle you can see in top view, and a rake angle and a relief angle you can see in front view and side view respectively. Then come to the next point. It is a nomenclature and what is tool signature. There are three coordinate systems which are most popular in tool nomenclature. What are these? Machine reference surface, again called as the MRS method. Orthogonal tool reference system, again it is called as a ORS system, or orthogonal rake system for tool nomenclature. And third one is a normal reference system, again it is called as NRS system. For our syllabus, we have only ORS system of tool nomenclature. In examination, that ORS system will ask the shape of tool is specified in a special sequence, and this special sequence is called as a tool signature. When the tool is specified, when you go for market to purchase the single point cutting tool, you have to specify tool signature. That means the special sequence to specify that tool, that special sequence is called as a tool signature. Okay, how the tool is specified in ORS system? First, back rake angle is defined. Second value is side rake angle in this system. Third value is clearance or end relief angle. That means first two is related with rake angle. Next two is related with relief angle. Again, it is a end relief angle or side relief angle. And next two is end cutting edge angle or cutting edge angle, and in that first is a end cutting edge angle and second is a side cutting edge angle. So first two angle is a rake angle, next two is a relief angle, and next two is a end cutting edge angle, and last value in that tool nomenclature is a nose radius. Okay, so in the examination, a typical tool signature of a single point cutting tool is one sample is written here 0, 7, 6, 8, 15, 16.8. In the examination, this sequence you have to specify, and this procedure ORS system of tool nomenclature, tool signature is given. Maybe this value will be changed. But in the examination, you have to specify what is 0, what is 7, what is 6, 8, 15, 16.8. So you have to write the answer in this fashion. Here the tool signature indicates that the tool has 0 is a back rake angle. So first value is of back rake angle. Second value 7 is side rake angle. Back rake angle you can see in front view, side rake angle you can see in side view. Okay. Next value 6 is given in that tool signature. That 6 is a end relief angle. End relief angle, and next 8 is a side relief angle. This again you can see in front view, and side relief angle you can see in side view. Okay, so first two is a rake angle, second two is a relief angle, and next 15-degree is given end cutting edge angle, and next is 16, which is side cutting edge angle. All these value of angles are in degree, and last one is a 0.8, which is a nose radius, which will measure in mm. In this way, you have to specify the tool signature. Your answer should be like this. So at the end of this session, you can understand the angle of single point cutting tool and how the tool is tool is specified, that is nothing but nomenclature and tool signature. Thank you for watching this video.